Hi all. Today we're going to talk about Newton's first law, also called the law of inertia. So here's a thought for you. Let's say you're driving your car and you take your foot off the gas. What happens to your car? Yeah, it slows down, of course. So what causes it to slow down? That's really the big question. And hopefully you're saying, well, air resistance, friction with the ground, things like that. Seems pretty obvious. And we'll call all of that stuff, whether it be air resistance or with the ground, we'll all call that friction. So that's the term we're going to use. Now why do I ask? Because this guy, Galileo, asked the same thing. And you might be saying, why is there a picture of a finger next to Galileo's name? Well, I'm not going to tell you now, but I want you to ask in the middle of class tomorrow. That's when I'll tell you. But you need to ask. Well, what does Galileo have to do with this? Well, very simply, he was put under house arrest some time ago, and during this time he did some experiments with inclined planes. And everyone knows, I think everyone knows, that if you roll a ball down an incline, it speeds up as it goes down the incline. And of course, if we roll a ball up an incline, it slows down, eventually comes to a stop. But what Galileo did is he realized something that no one else did. He said, what happens if I sand those boards down? What happens if I get rid of this friction? Where will the ball go? So he said, well, what if I start the ball at some point and it's going to roll down an incline, and then when it gets to the bottom, I'm going to let it roll up the incline. How high will that ball go? What he found is as he got rid of the friction, the ball would end up at the same height at which it started. Wow, that's a huge idea, big idea, same height. See, this led to some major understandings in physics. So he did a little thought experiment, and he said, okay, what happens if I roll a ball down an incline, but I don't let it go up? Instead, I just let it roll horizontal and get rid of friction. Obviously, we can't do that. We can't just get rid of friction. But he said, what if? And he realized the ball was always trying to get to that same height. Never does get to that same height if we let it go on a horizontal plane. In other words, it goes on forever. Kind of interesting. He had a very special name for this. He called it inertia. He said a body wants to keep doing what it was doing. Key idea. Big idea. It wants to stay at rest. If it's at rest. It wants to move. Same speed, doesn't change speed. And then when it moves, it wants to keep moving at that same speed, and it doesn't want to change its direction, so straight line. That's what it wants to do. That's what inertia is. Okay, let's look at my daughter.
Hi. Here we go. 1, 2. Is that the 2?
Take a look. What happened? She was laying there. I pulled the blanket out from underneath her. Did it move? Here it is. Pretty much stayed where she was at. She had inertia, a resistance to that change in motion. Just for fun, let's put the dog out there. Notice, a lot less mass, smaller, same results. So this is all about Galileo coming up with the idea of inertia. Here's a great cartoon that helps explain this idea. We talked about an object at rest. What about an object in motion? We have the zebra. He's moving, the stripes are moving, comes to a quick stop, and the stripes continue to move. Again, doing what it's already doing. Objects in motion continues in motion. We have our car. Object in motion continues in motion. The car stopped, but the person kept going. That's why it's important to wear your seatbelt. The opposite, the object's at rest. We have an anvil. Can't get that thing moving. It's got a lot of mass, a lot of inertia. So let's say you're outside and you're fixing the International Space Station and you accidentally get pushed off of it. Think about what inertia means. It means you're going to keep doing what you were doing. So you got pushed off it. How much additional force is needed to keep you moving? None. None at all. So, do any other forces act on you? No. There's nothing new acting on you. And of course, your inertia keeps you going. It doesn't slow you down. These are huge ideas. If you understand that, inertia should be very, very easy. Here's my good friend Calvin. He sees on a test, explain Newton's first law of motion in your own words. By the way, Newton's first law of motion, another term for that is his law of inertia. So, he's getting in the groove. Boing! He feels like Newton now. So he's got an idea. Boing! Newton again. A little older though. Doesn't look like Newton to me, does it? Maybe in the face. And of course, I love loopholes. I do too. You see, this guy here, he took Galileo's ideas and made them his own. Galileo came up with inertia. Newton turned it into a law. We'll talk about this picture in class. Frank and Ernest, right? Sorry I'm late, but a body at rest, you know. How perfect. So let's see if you really understand what's going on here. Which way will the bullet go? Well, the bullet itself, right? It's trying to go around and around and around, or it does go around and around. Why? Because the bullet wants to go straight, but it hits the wall. What's the wall do to it? If you said pushes on it, you're absolutely right. So it turns it. It pushes it. Just like if you try and go straight and your little brother gives you a push, you end up changing directions. So now when it hits this part, it goes around and around, it comes out here. Is there a wall to push on it? No. So it ends up going straight. There's no reason for this thing to change direction. Remember, that's inertia. It goes in straight line motion. Same thing with the yo-yo. We swing this around our head. The string breaks. Which way does the yo-yo go? Well, which way was it going beforehand? We know the string was pulling it back into a circle. It wants to fly off. Gets to this point. Which way was it going last? that direction. There you have it. If you could answer that, you're well on your way. Let's see. Watch these guys. Notice the direction he was going last. Straight line. Oops. So let's think about this. That guy could have been the Earth. The center of the swing could have been the sun. The ropes on the swing are pulling the swing around in a circle. Gravity pulls the Earth around the sun. So what would happen to the Earth if suddenly the sun were to disappear? Well, if you said it would go off in a straight line, you are correct. Here's the sun. Here's the Earth. It's going around like that. If the sun were to just suddenly disappear, where the direction it was going last is the way it would go. Straight line, constant speed. So let's recap. Inertia simply is the fact that a body at rest will stay at rest, and a body in motion will stay in motion. However, that motion will be at constant speed. I didn't really talk about that, but think about it. Why would something speed up? In a straight line. Again, why wouldn't it be in a straight line? Unless something pushes on it. So, unless a force acts. Okay, there you have it. See you in class. Sure.